for an angle when using trigonometric functions such as sine, cosine, and tangent. What we learned about sine, cosine, and tangent was to remember Sohcahtoa. That'll help us remember how to set it up. Sine is the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. Tangent is the opposite side divided by the adjacent side. So in the previous video on labeling, what we said was to label in a particular order, and then you don't have to worry about what adjacent means, but that shouldn't matter if you just take the time to understand what adjacent means next to, which will mean it'll be the side next to the reference angle. So let's do a problem. We're going to be solving for an angle. So we're missing the angle here. I labeled it x. And in order to solve for a missing angle, you need at least two of the sides. You can even have three of them, but you need a minimum of two of the sides. So let's make up some sides here. So we could take this problem. We said first we want to label the hypotenuse, and the hypotenuse is here. It does not have a number, so we will not be using it. Second, we said label what's opposite, and when we say opposite, we mean opposite of the reference angle. One way to look at it is to pretend you're standing there and you're looking from that spot. That's your reference point. That's why it's called a reference angle. So standing at that point, which side is opposite of you? Well, that would be across. So across or opposite of you would be 20. So the 20 is the opposite side. And the third one is adjacent. Adjacent means next to. It's the side here next to the reference angle, but not the hypotenuse. The hypotenuse will always have that same name. The other two sides can change depend on where your reference angle is, or where you're standing, you could say. So what we look at so far is when we labeled it, the adjacent, the leftover one, we have the number 20 used, and we have the number 12 used, and we have no other number for the hypotenuse. So this is one of the problems where you need to use a specific trig function. You need sine, cosine, or tangent. You don't have the choice to use any one. You would have that choice if you had the third number. When you have all three numbers, you can choose sine, cosine, or tangent. So right now we're constrained by the two we have, and we only have the opposite and the adjacent. So looking at our little acronym here, Sohcahtoa, which one is using the O and the A, the opposite side and the adjacent side that we highlighted? Well, it would be tangent. You see, tangent uses the opposite side and the adjacent side, and those are the two we have. So that would indicate we're going to use tangent. So we're going to say tangent of the angle x, and so that's what's always going to go in that spot. Next to the angle x, next to the tangent will be the x. That is always with the angle. So if we had a number for that angle instead of an x, if we had 32 degrees, we would have tangent of 32 degrees. But right now, we don't have the angle, so we have the x. So we're always going to write it in that order. Tangent of the angle is equal to the opposite side divided by the adjacent. That's what TOA stands for. Opposite divided by adjacent. So the opposite side is 20, and the adjacent side is 12. So we could use a calculator to do that. What's 20 divided by 12?
It's about 1.6666.
Okay, I'll round it to 1.67. It's 1.66666. So in order to understand how to use the calculator, we want to see where we leave off here. So what we have is tangent of x equals 1.67. So what that really means, what we're looking at, is the ratio of the opposite side divided by the adjacent side is 1.67. So the bigger one is 1.6 times the other one. And to make that particular angle, or with that particular number, 1.67, it would make a particular angle no matter which triangle we made. So the question sometimes comes up of how do you get the x by itself, and how do I know whether to use the button on the calculator that says tan or the button that says inverse tan, tan negative 1. So we got to understand that when we're looking at solving an algebra problem, we want to get x alone. So in order to get x alone here, we can't just divide the word tan, because the tan and the angle are together. It's saying tangent of that angle, x. So in order to separate it, we need to do the opposite. So for example, when we do a normal algebra problem, we do PEMDAS backwards. We say, is there any addition or subtraction? Here it is, yes, plus 1. And we do the opposite, minus 1. And again, our goal is to get x alone, so 2x is 2. So then we have times here, 2 times x, so we do the opposite. Just like we did the opposite of plus is minus, we do the opposite of times is to divide. So we divide both sides. Y again is to get x by itself. X equals 1. So we're going to use that same principle with the tangent and with sine and cosine. When we have sine of x equals a number, we want to get x by itself, so we need to do the opposite, just like the opposite of plus was minus, or the opposite of times was divide. So the opposite of sine is inverse sine, sine to the negative 1. So we do that to both sides, just like up here. We had to add to both sides to keep it even. We divide to both sides to keep it even. So when we do something on one side, we do it to the other. It's following the same rules we learned in algebra. So again, the reason we do these things are to get them canceled out. So x can be by itself. So here we cancel out sine and inverse sine, because sine times inverse sine is 1, just like it'd be sine times 1 over sine. Or we could write it another way, sine times the inverse of sine. Well, that's sine over sine, which is 1. So we got rid of it and canceled it into the number 1. And you don't need to understand that to make sense of this. I just want to really emphasize why we're doing what we're doing. So we've gotten x alone, and we have sine of negative 1 and the number 0.54. So this is what we would enter into the calculator, exactly the way it's written. X is now by itself, which is our goal. We would push the inverse sine button. So we would push 0.54 in the calculator, and then second button, and then inverse sine. Oftentimes on the calculators, the inverse sine will have you use the second button to get to the opposite or inverse. Let's see, let's turn this into scientific calculator. So here would be sine, but we want inverse sine. So we push the second button, and there's the inverse sine. So let's do this one, 0.54, and then inverse sine. So 33 degrees. So let's go back to that problem we were doing and finish this. So what we have here is tangent of x equals 1.67. So we want to separate or get x alone, solve for x. So we're going to multiply inverse sine to both sides, because tangent and inverse tangent. Tangent and inverse tangent are opposites. I've written it here before. Just like times and divide are opposites. Tangent and inverse tangent are opposites. And when you multiply them by each other, it becomes 1 or cancels out. So we cancel it out, x is now alone, and we're going to push the tangent -1 button, inverse tangent, in our calculator. So I'm going to pull the calculator back up. I will push 1.67, and tangent's here, so I have to push the second button, second tangent. So 59 degrees. So what we found was that the angle of x is 59 degrees. So that's how we would set up a problem and how we would cancel out sine or cosine or tangent when solving one of these problems, the way we would get x alone. So I was going to try to move that down. Let's try another one. And we'll make it go a little bit more smoothly because I won't explain every single step. I'm going to try to solve for this angle up here, call it an x. I'm going to this time give you 100, and I will give you 184. So the first thing we want to do is label. I recommend always label the hypotenuse since it never changes. It's across from the 90. Then pretend you're standing at your reference angle x and label which one would be opposite or right across from it. And that would be 100. And then the leftover one is the adjacent. It's next to the reference angle. We have our reminder, Sohcahtoa. So since we only have two of the three numbers, we don't have the adjacent side, we have to use the one particular ratio. We can't choose from the three. So in this case, we have the opposite and the hypotenuse, these two numbers. The opposite side we have a number, the hypotenuse we have a number. So we have to use sine because that's the one that uses opposite and hypotenuse. So what we now remember is that sine of the angle will always equal the opposite side divided by the hypotenuse. So we can take this particular problem and say sine of the angle equals the opposite 100 divided by 184. So calculating that in our calculator, 100 divided by 184.
It's about 0.5434.
So again, algebraically, and even on your calculator, we want to remember we're going to cancel out or separate the x from sine by multiplying it by the inverse. Really what inverse sine is 1 over sine. So there's one on the top, one on the bottom. It cancels out. But we conveniently write it a little differently. We write it as sine to the -1. Okay, if you remember the exponent rule, 1 over x equals x to the -1. So the inverse of x can be written in either way. It could be 1 over the number or the number to the -1 power. The negative power brings it down, if you remember your exponent rules. So sine to the -1 will cancel out. X is equal to sine of -1. That will be the button we push, of 0.5434. All right, so 0.5434. Another thing to keep in mind, we push our second button. Here's our inverse sine. Here's the button rad. Be sure not to push that if you're on a calculator on the computer, but on your normal calculator, you'll see on the top a D, an R, or a G. Always make sure it's a D, or degrees. That's what we're using. In other math and Algebra 2, you learn about the unit circle. You'll use radians instead. So we enter the number 5434. We push the second button and sine. So 32.9 degrees. 32.9 degrees, if we round it to the nearest whole degree, would be a 40-degree angle. So what we can do is find a missing angle and calculate when we have two or three sides what what a missing angle is. And we can do the reverse, and that'll be another lesson, how to solve for a side. All right, I hope this was helpful. And for those of you who enjoy the reason why things are the way they are, or each step, I hope it was a little bit useful to understand what we're doing and how to use it. Have a good day.